Hi everyone! Today we're going to look at a Desmos tutorial for finding a line of best fit or doing some kind of regression. And the cool thing about Desmos is you can do almost any kind of regression that you'd like. Your handheld graphing calculator does quite a few, but on Desmos we have a little bit more unlimited possibility because it's just all about how you type in the equation. So if you've never used Desmos before, you're going to go to www.desmos.com. And when you get there, you'll get to a page that looks something like this, and you'll want to start by clicking on Start Graphing. Alright, so then what's kind of nifty is up in the upper right-hand corner there is a little question mark, and that question mark, although it is also for help, it gives some tutorials on how to do some cool things. So what we're going to look at today is we want to look at our tutorial for a regression. So go ahead and click on Regressions. And then they give you some prompts to walk through. So first, let's get some data. Head over to Google Docs and copy and paste this sample data. Okay, so I'm going to open that in a new tab. And it looks like I have some X and some Y data. Let's see, we have an X position and a height off the ground. So let me see if I can split screen this. Okay, so to do that, I can copy and paste. Let's see what happens when I just straight copy and paste, because I also want to show you how to do it the other way. So what's pretty cool about this is that it will just create a table for you. Of course, it doesn't keep the titles, but it does create a table for you. Now where it says awesome, click here to add a new item. This is where you could also go if you were creating your own table, if you didn't have data in a way that can copy and paste. Okay, so I could go to table and just hand type those things in. Obviously this is a little quicker. Okay, but for the purposes of the regression, once you have your data, you want to create an expression. Okay, now notice what I'm typing in here. I'm going to type in Y1, and they give you some hints on how to create those characters. Cool tip, you can also do this on your phone or iPad. There is a Desmos app, and there's an online or an on-screen keyboard where all these keys can be found. So you can actually do all of this on your phone while you're working on your homework as well. Okay, so I'm going to type in Y1, and it won't work if it's just Y. You have to have Y1. And then I'm going to do this little curvy equal thing. Again, won't work if it's an equal sign. Must use the correct symbols here. mx1 plus b. So anywhere I'm using x or y, I have to put that 1 with it, and the reason for that is that it tells me that it's pulling from this data right here. This is x1, this is y1. Okay, so then it says let's check our model. Residuals are the difference between your data and your model. So click here to add them to your table and plot them on the graph. We don't do a lot with residuals in our textbook, but if you wanted to know them, this tells you whether things are over or under. So here's where Desmos is pretty cool, and you can change it around, like I said, almost infinitely. It looks like a straight line is an okay model, but not a great model. So they said, let's edit this to make it a better fit. Let's try doing a quadratic instead of a linear. So I'm going to use ax1 minus h. Now to do squared, you can either use the online keyboard or you can do the little caret and then the 2 plus b. Alright, so now you can see that I am much closer to my data, and these residuals down here, these red points, are almost all right at 0, meaning that the green dots are very, very close to the black line. The farther away they are, the red dots will show what that difference is. So I could change this to be something cubed. I could see what a cubic looks like. Let's go back, because this looks pretty good as well, but let's go back. How can we prove to ourselves whether the cube or the squared is a better model? Well, if I look at my r squared number right here, this 0.9994, that's a pretty good number, right? That's telling us that we are pretty accurate. If I change that back to a squared, I am slightly higher, 0.9996. So at this point, both are pretty solid models, but the quadratic model is actually better than the cubic model. Now the last thing you want to note is that down here at the bottom it does tell you what numbers actually fill into your model. It's one thing to know that it's a quadratic model, but we need to know what the actual numbers of the quadratic model are. So this tells us that A right here in front is negative 0.0447748. We could fill in H with 15.7652, and we can fill in B with 19.292. All right. Hopefully that's helpful. You can play around with it a little bit on your own, and you can do linear, quadratic, cubic, any kind of exponential. You could do a logarithmic model. Basically, the sky's the limit. If you have a parent function, you can create a regression out of it by using y1, x1, and this little symbol right here.